On June 24, 1948, Soviet forces closed all ground access routes into West Berlin. 2 million civilians were cut off from their supply lines. The only remaining corridor was airspace. What followed was not a rescue mission, it was a logistics test at the edge of operational feasibility. The Berlin Airlift ran for 324 days and delivered 2.3 million tons of cargo using only 3 narrow air corridors. This is the breakdown of how it worked. Fact 1. The air corridor system was defined by physical geometry, not politics. 3 20-mile-wide corridors connected West Germany to West Berlin. Aircraft flew in at altitudes between 1,000 and 10,000 feet, separated into assigned altitude bands. Each corridor could handle only one direction of traffic at a time. Outbound traffic used separate corridors to prevent head-on conflict. The total usable airspace was limited. This meant throughput was fixed by altitude, time, and width. Every constraint that followed emerged from this initial box. Fact 2. Berlin had 3 airfields, but only Tempelhof and Gottow were fully operational at the start. Tempelhof's runway was 6,000 feet long, built for smaller aircraft. The largest available cargo planes were C-54 Skymasters, which required nearly the full length for landing and takeoff. Each landing cycle consumed time. Aircraft approached, touched down, taxied to unloading zones, reversed the process, and departed. Initially, this process took over an hour. At that rate, the maximum daily tonnage was far below what the city required to survive winter. The constraint was not aircraft availability, it was ground time. Fact 3. The minimum survival threshold for West Berlin was 4,500 tons per day. This figure was not symbolic. It was derived from caloric requirements, heating fuel needs, and industrial inputs. 2 million people needed 1,600 calories per day minimum. Flour, dehydrated potatoes, and fats were calorie-dense and prioritized. Coal represented the largest fraction of tonnage because it powered electricity generation, heated homes, and fueled factories. During summer, food dominated. As temperatures dropped, coal loads increased to 70% of total tonnage. The ratio shifted based on temperature forecasts and stockpile levels. Every flight's cargo was calculated against this equation. Fact 4. Ground turnaround time was the primary bottleneck. The solution was systematization. Unloading crews were pre-positioned at exact taxiway points. Cargo was pre-staged in standardized loads. Trucks moved on fixed schedules, timed to aircraft arrival intervals. Pallets were not yet standard in 1948, but improvised platforms allowed forklifts to remove entire loads in under 10 minutes. Crews worked in rotations. Aircraft engines stayed running. Pilots did not leave the cockpit. The average turnaround time dropped from over an hour to under 30 minutes. This change more than doubled effective throughput without adding aircraft. Fact 5. The safe landing interval between aircraft was initially set at longer intervals to allow for approach errors, wind shifts, and go-arounds. As procedures tightened, the interval was systematically reduced. Ground-controlled approach radar became the primary landing system. Controllers issued verbal instructions to pilots based on radar tracks, guiding them through clouds and darkness. The operational standard became 3-minute intervals. Aircraft departed bases in blocks, timed to arrive over Berlin in sequence. This required absolute procedural discipline. Pilots who missed their approach slot were not allowed to circle back. They diverted to their origin base and returned to the queue. No exceptions. At peak operations during the Easter Parade in April 1949, the combined rate of landings and takeoffs on the same runway reached 1 aircraft movement every 90 seconds. Fact 6. The third major airfield, Tegel, was built during the airlift. Construction began on August 5, 1948. The site was a former Wehrmacht training ground in the French sector. French engineers and German laborers worked in overlapping shifts. The runway was built to 7,500 feet, longer than Tempelhof, and designed to handle heavier aircraft. The first aircraft landed on November 5th, 90 days after construction began. Tegel's addition increased system capacity by 33%. The runway surface was pierced steel plank over compacted earth initially, then reinforced with asphalt as use intensified. Continuous aircraft operations created continuous surface degradation. Repairs occurred at night in sections while traffic shifted to other runways. Fact 7. Aircraft attrition was measurable and predictable. C-54 Sky Masters and British Dakotas flew multiple sorties per day. Maintenance cycles were compressed. Parts inventories had to be positioned at both German bases and Berlin. Weather, fatigue, and mechanical wear caused failures. 17 American and 8 British aircraft were lost to crashes during the airlift. The accident rate stabilized once procedures hardened, but the total flight hours exceeded normal operational limits. Engines were swapped on accelerated schedules. Airframes were inspected between sorties rather than after mission intervals. Spare parts became a dedicated logistics track within the larger operation. This required pre-positioning entire engines, landing gear assemblies, and avionics in Berlin flown in as cargo before they were needed. Fact 8. Weather was the largest uncontrollable variable. Berlin's winter brought low clouds, freezing rain, and fog. Visibility below minimums grounded operations. On the worst days, fewer than 100 sorties could be completed instead of the target of 700. The solution was not meteorological. It was statistical buffering. Stockpiles in Berlin were maintained at a minimum of 2 weeks of supply. When weather closed the corridors, the city drew from reserves. When conditions cleared, sortie rates were increased beyond normal capacity to rebuild the buffer. Crews flew extended hours. Aircraft cycled faster. The system absorbed variance by operating above the baseline when possible, not by smoothing the baseline itself. Fact 9. Block scheduling was developed to manage landing flow. Aircraft departed German bases in groups, spaced to arrive at Berlin in sequence. Each block was assigned a specific altitude and a time slot. Planes flew at altitudes between 5,000 and 7,000 feet, separated vertically by 500-foot increments. Controllers knew the exact sequence and monitored adherence. Deviations were corrected early in the flight path, not at approach. This structure allowed multiple aircraft to occupy the corridor simultaneously without risk of collision. It also meant ground crews knew precisely when each plane would arrive, which cargo it carried, and where it needed to be directed. The scheduling system required coordination across bases, air corridors, and Berlin airfields. Radio communication, written logs, and teletypes transmitted updates continuously. This framework became the foundation for modern air traffic control logic. Fact 10. The airlift became self-sustaining in spring 1949. Daily tonnage exceeded 5,000 tons regularly, well above the survival threshold. Stockpiles in Berlin grew. The operation transitioned from crisis response to stable supply system. On April 16, 1949, a single-day record of 12,941 tons was delivered in 1,383 sorties. This peak demonstrated the system's maximum throughput capacity. The blockade was lifted on May 12th, but flights continued through September to ensure reserves. By the end, the total tonnage delivered was greater than the entire city's pre-blockade annual imports. The constraint was never the cargo. It was always time, space, and turnaround. If you want more breakdowns of engineering systems that operated at the edge of what was possible, subscribe to Grandeur Decoded.